Put that thing away.
All right, everybody, I think we're going to get started. So, did anybody come to the last one, which was like over 2 years ago, maybe? Anybody?
2 years ago?
I think so.
Oh my God.
We had some things happen in between, like company, like proposal, lots of work and expansion, stuff like that. So we were a little busy, but we're finally trying to get back around to doing this. So I'm hoping to do this quarterly, unless I can be compelled to do otherwise. Right now, all the guys you're going to see speak tonight are with Visionist. It's our space, but that's not a requirement at all. If anyone has any interesting things they want to talk about, just let us know and we'll figure out a time. I actually just got someone on Meetup, a React Rally speaker, actually messaged me and said she might want to try coming to this Meetup group. So no promises, but that's kind of like a teaser. We might have like a real React Rally person here. Oh, we'll have to talk. So yeah, without further ado, Enrique and Josh.
I should introduce yourselves.
Yeah. I'm Enrique Caballero. I'm a software engineer here at Vision. I've been here for 3 years.
I'm Josh Gordon. I was an intern 4 summers ago, and I've been a full-time software engineer here since January of 2015.
We're going to be talking about Create React App. How many of you know what Create React App is? Cool. Awesome. So yeah, so our talk's more, it's going to be like, go ahead.
How many of you have strong opinions on Create React App? Okay, that's nice.
Okay. Yeah, so we're gonna go like around like 2 ideals pretty much, like when to use Create React App or why not to use Create React App, like why to use it, why not to use it. So let's go ahead and start. First up, like configuration. In not using Create React App, like you pretty much call all of the shots, like how your project's gonna be configured, whether you want to use Webpack, do you want to use Prepack, do you want to use Parcel, do you want to use Rollup, do you want to use like Babel? You don't really have to use Babel. Do you want to use Cess? Do you want to use Less? Do you want to use Post CSS? Up to you. All the knobs are at your disposal.
On the other hand, Create React App comes with everything pre-configured for you. So you just say Create React App foo. You have an app called foo, and you can run npm start, and you're ready to write React code. So Create React App does actually expose a couple of configuration knobs for you to turn. One example is proxy, which lets you use the Webpack dev server proxy.
Which is totally made up because that's not really what it does. It's hiding behind the scenes. What it's doing is grabbing that from package.json and adding it to your Webpack dev server config, adding a proxy attribute to your configuration.
And then if you want to do anything more serious than that, you need to fork off onto a Create React App replacement like React App Rewired, which I actually used because I needed web workers in my React App. And Joel's used it too.
So without Create React App, you might spend more time configuring your project, in the beginning at least, before you actually dive into writing React code, which is kind of what Create React App tries to solve. Like Dan Abramoff says, configuration should not stand in the way of you getting started. But this has some like pitfalls because you end up hiding all the configuration and options from the developer, especially when you're dealing with newcomers. You don't want to hide that because I found this quote online, which is actually pretty good. React does require some amount of configuration to get started. Like if we decide to not expose new developers to this aspect of the development, like we are failing them as fellow developers, like teaching them only the good parts and hiding the difficult ones behind the scenes. Like this will probably give us like a bigger number of newcomers, which is great, but at the same time, it doesn't give us developers ready to take our place. So if I'm the only one on the project that knows how to deal with Webpack, and all the other bundlers, like I get hit by a bus, what are they going to do, right? The learning curve.
Oh, sure. So one huge disadvantage to not using Create React App is that Webpack and all of the things that go along with it, Babel and whatever, have this giant mountain of tech debt that you have to climb over before you get to actually write React code. Whereas Create React App sort of digs a tunnel through that mountain so that you just go from where you start to writing React code without having to talk about.
Then there's this thing that you can do whenever you have Create React App, but to be very honest, the moment you run this is pretty much going to be your face. Because you're going to be looking at config files that really weren't meant to be exposed to the end user. They're very scary, and although they are very commented, which I give props to them, they still are very very, very difficult to understand for someone that just wants an introduction to Webpack. So if you are going to use Create React App, just remove the eject script from your package.json to avoid like painful situations.
All right, upgrades. Upgrades, yes. So with Create React App, you get upgrades for free whenever you update your package.json to roll up to the new version, and it's whenever the community gets around to providing them to Create React App.
When you don't use Create React App, you can upgrade pretty much whenever you want. This has a lot of pitfalls. Like, for example, let's say Webpack 4, Webpack 5 comes out now. You want to upgrade to Webpack 5. That you might run into problems like some plugins don't really support Webpack 5. Then that's on you. Versus like in Create React App, like he said, like the community gives you that update, but you have to wait months maybe until they feel comfortable enough where the plugins that they use for Create React App are supported by the new version of Webpack.
So using Create React App is a lot like using a very stable traditional Linux distribution like Ubuntu or Fedora, where you get an update every 6 months and that's it. Whereas using Webpack and Friends is a lot more like Gentoo or Arch, where you're just sort of, you can do whatever you want. But if it breaks, you get to keep both pieces.
Right. So what does this mean? What does all this mean? Like pretty much it's like you just use whatever works for you. It depends on the type of developer you want to be. If you're someone that you're a DevOps guy like Josh here, and then you want to you have to write some React applications. Sure, Create React App works great for you, right? Because you just dive into the React, you create a React application, you're done. If you're a UI developer, like 8 hours a day, you might want to know how the basics work under the hood, right? Because you might want to know what Webpack is and how it works and what Babel is or PostCSS. But then again, that's my opinion. Like we both have differing opinions on how Create React App is, and we all do. There is no right or wrong opinion, to be very honest. That's why we think like we both concluded equally. Just use whatever works for you.
There's no tool is wrong for every job, and no tool is right for every job.
Yeah, that's our talk. Questions?
Yeah, so I failed to mention, slightly different format this time around. We're doing a bunch of shorter talks, and feel free to interrupt anybody. Like,
Yes.
just speak out, interrupt, do your worst, your best.
Trying to move away from the whole workshop scenario to like more of the like lightning, like quick talks with like a lot of subject matter to get you guys a little interested in like, some of the things that we've been doing. But yeah, guys, any questions?
Because you're talking about the freedom and the fact that it's not for native,
Mm-hmm.
how do you judge when you have vulnerabilities, or you just have to go into all the configuration anyway because you have to find out how bad is bad going to be when you actually start taking it?
Digging into like the Create React App configuration, or
Yes. Because if you have to
Sure.
create something that is not going to be hacked, or that is going to have
Right. So Create React App really sits on the front end.
Yeah.
So unless you're worried about like XSS or anything like that.
Yes.
Okay. So that boils down to the version of React that you're using, which you can go into Create React App and see, right?
yeah,
So
it's all open source, so you can look at the code on GitHub if you want to. Yes. And then you can just keep track if they track the vulnerability, they maybe put a ticket in or an issue for it, and then you could follow the thread there on GitHub. But yeah.
I think the only advantage that not using Create React App gives you is you see there's an exploit. You go in and
You can fix it.
you can upgrade your React version, patch it
Yes.
right away. Whereas Create React App, you might have to wait a couple of days to get onto that next version. Although if it's a security fix, it's probably going to be merged in pretty quick.
More questions?
Kind of just sort of tailing on that, Create React App is more focused on the code process. So you still have full control of your dependencies and making sure that you're not pulling anything extra. So maybe the version of Babel, polyfill, or what is polyfill and stuff, that might be, but the rest of Create React App is more focused around building your application, not having to worry about the build process. So the vulnerability would be more you have to be aware of it, like your CI and stuff like that. But before actually deploying it, there's really any difference between that versus just using Webpack and configuring it yourself.
Anybody else? Okay, so next up is Chris Brainerd. Over there.
Here, right? Right, he spun down the server. This is fine. This is fine.
While he's getting set up, in case anyone needs them in the bathrooms, if you go back out the front door and hang a left and walk down the hallway, the rooms are over there.
Yes. Cool. So that was momentarily terrifying. Okay, so I'm going to be talking about how to make React work with things that don't like to work with React. This talk's going to focus on Leaflet, which is a mapping library. If you've ever been to Craigslist and seen their map, that's built using Leaflet. Mapbox is built on a lot of the old original Leaflet stuff. Also, don't use Craigslist as an example because their UI doesn't look great, but Leaflet can look really nice. So the main problem that you have when you have two libraries like this is that React, when you feed it into that, React DOM.render and feed it a div or whatever, it wants control over everything down the DOM tree, all the way from there down. And it's not going to be happy if you take control away from it, from some things. It won't always necessarily complain. It will just keep overwriting the div that you're changing or the styling that you're changing. And so the problem that you have when you work with something like Leaflet, or if any of you work with D3, which is a really great, really, really difficult sometimes data visualization library, is that it's really difficult to get the two to talk to each other and to kind of make both things happen at the same time, hence the Thunder DOM. We want two libraries to go in, but them both to play nicely, hopefully. So, if you've worked with React much, you've seen this or something like this. This is the current React 16.3 or whatever we're on lifecycle. It dictates how, when data comes into your app or to your component, what actually happens, what functions are run, what the end result is, should it update, should it not update, should it send data down, should it not send it down. And if all of your components are React, this is really nice because everything's using the exact same language. You don't have to do any translation. You just say, hey, I want to pass data down to this component. The next component speaks the same language. And so it's okay, that's a prop. I know what to do with that. The problem is that when you want to have Leaflet somewhere down in there, Leaflet doesn't know what to do. Leaflet does not really have any sort of internal life cycle like that for dealing with data. It just expects, I'm going to put stuff on the DOM and nobody's going to touch that. So the question we have to figure out is, okay, who's telling Leaflet what to do with that? And so that is our job as developers. So this is kind of confusing, and it's going to differ from library to library how exactly this works. We're focusing on Leaflet because A, I like maps a lot, and I think they're cool. And B, it's relatively straightforward compared to something like D3, which does have its own completely separate version of this entire life cycle that looks nothing like this. And that's horrible. So we're not going to subject you guys to that. So with that, we're going to hop over into some code. Okay, so how do I make a new tab? It's not that button, it's the other button. This is a Mac, everybody, and I'm not used to that. Command T. There we go. Okay. Okay, so I'm going to walk through a couple of examples of kind of what things look like at various stages of, hey, I just want to put a map using this cool library. Maybe you're building, a restaurant's website or something that's not very data-driven, and so you just need to put a map on. That's actually really straightforward, and it really doesn't get very complex from there. Oh, that's the wrong folder. Bear with me. That folder. That's the one that we wanted. Source, just a map. Okay. This is all it is, like literally all it is. And this code is the actual code that's running over the other one. So all of these individual things, you don't need to know what happens, but basically just when the component mounts, when React is first going to put that thing on the DOM, we're just going to tell Leaflet, hey, there should be this div with an ID of map host. The l.map takes an argument that's just going to be a div's ID. And it makes a map. That's it. That's as complicated as it needs to be.
Can you use a font size with?
Yes, maybe. It's a Mac. I don't know. I figured it out. Okay. Better?
Yes.
Okay, cool. Yeah, so like that's literally as complicated as it is. So if you're not making something where the map is going to be data-driven or something where you don't really need two-way communication, you just need to put a map in a place, this is all you do. You don't really need anything complicated. If that was it, however, I wouldn't be giving this talk. So now we're going to jump into more reactive stuff. So to-dos, because that's what everybody likes to do for some reason. So this is a fairly simple to-do. I didn't do editing because I'm lazy, but you can add things, you can delete them. It's a really bad example if I do the same text for each one. Second thing, you delete them, they show up. Cool. So if we hop over to the code, oh, my thumb is on the trackpad. Okay, so we're basically just defining a bunch of individual functional components. Don't pay attention to the list item and all of that stuff because that is just the material UI library that I'm using. These could be divs and spans. It doesn't really matter. But, so for the to-do, we have this function that's just going to spit out something where we have a to-do.text, and then we give it a function that's going to remove that to-do. Pretty simple. You look confused. Are you fine? Okay, I don't want, with everybody so far? I know that I'm using not standard divs, which is a poor choice, and I realized that after it's too late, but so then we can put those all into a giant to-do list where we're taking the to-dos that we have, we map over them, and then we spit out a bunch of to-dos onto a document. So where it gets more complicated is what happens if we want to map. So let's put a couple points in this map. This is using the Google Places autocomplete API, so we'll toss it. Rockville, that's where I live. There, cool. Okay, let's hop over to how this works. Okay, so we have this app. It's going to keep track of the to-dos just in component state. We have a function for add to-do. This part is part you don't need to pay any attention to. This is just hitting the Google Places API and coming back with an actual location. We're going to update the map, which is the function we're going to dig into in a second. So here's where we're actually doing our leaflet stuff. So if you remember back in the first example, we just did component did mount, put the map on the DOM. That's it. We're done. Here, however, we need to do stuff after it's loaded. So we're going to store the map as this .map, so we're going to have access to it across the component, not just from only inside of that component did mount function. This is all almost identical to the thing we did in the other one. This .markers you can ignore. Essentially putting them into a feature group instead of directly on the map just lets me pan to them easier. Don't need to worry about that. And then we're doing something kind of not great over here in this update map. So every time you type in an address, you hit enter, it puts a point on the map, and it does that by calling this update map, which is going to remove everything from the map. So if you had 40 things in the map, it's going to dump all of them. It's going to then map over your to-dos, grab the lat long out of each one of them, so the actual geolocation coordinates, make a new marker, and then add the marker to the map. So this works. If we jump over to here, like it's technically not wrong that like, okay, I can delete the Rockville point. That works fine. But because we're doing this kind of naive way here where we're clearing all the layers every single time, that means if we have something where we're putting 600 points on a map and you want to remove one from the middle of those 600, you're going to need to clear absolutely everything, map over each individual 600 ones again, and then add those all to the map. So again, if you're doing something super lightweight, if it's slightly more complicated than a restaurant, this can still be fine. It's not necessarily bad. It's a lot easier, to be frank. But you're going to start to see performance issues because you're not really doing it in a reactive way. We're not treating each of these markers as a component, as a separate thing that has its own data, which is really ideally what we'd like to do. Dun, 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 and that's what we're going to do. So we're going to jump ahead to do with a map refactor. You'll notice this looks exactly the same. There's this. Cool. So the question is, what changed? So here, we only had this one giant component to do map app. There, we were creating the map, we were editing them, or we weren't editing the markers, we were adding the markers, we were removing the markers. Everything was happening inside of that one giant block of code, which kind of gives me a code smell right there. So here we're going to jump into a refactor, and we're going to have a bunch of smaller components. I'm putting them all into one file just so I don't have to keep clicking around. But so here we have a component that's just a marker, the marker by itself. That marker is only going to know the feature group that it's going to get added to, which is how we add it to the map, and it's going to know a lat long. And that's it. That component only handles that one thing. And so the weird thing that we have to do now is now we start to get our own little sync between the life cycles. So React has its own thing where it's going to mount the components, it's going to update the components, it's going to remove them. Leaflet doesn't have any of that. So this is kind of the translation. So okay, when this marker component mounts, we're going to create a new leaflet marker object and we're going to add it to the map. When that marker unmounts, we're going to remove it. And that's pretty much it. So if we scroll down to refactor, we don't need this anymore because each marker is handling itself. We are now proud parents of this app. So now, instead of just the div ID map host, we're mapping over to divs here, and we're just putting an individual component for each one of those markers. The end result is still the same, but now you can do cool stuff that's a lot easier, like having a little button in each one, where it'll pan to each one, because that marker knows where it is, it knows the map that it's attached to, and so just telling that one marker there, find the map you're attached to, and then pan to yourself is a lot easier than iterating over each individual marker, finding the one you want, trying to pull that lat long out of it, and doing all of that in this giant homogeneous. And then it should still work and everything, so that if we delete them, yeah, they still go away. Horribly lost anybody so far. I'm trying to kind of keep this high level, although to actually go through the code, I know we have to dig into like actual individual pieces of code, which isn't the important part. Okay, so what I'd like to do next is show a demo of kind of something a little more interesting than just this view app that you can do with this. So functional demo, which we'll put in large air quotes. So for this one, I want to go through the code first, and then we'll actually see it work. And hopefully by that time, you'll be able to see kind of where the React lifecycle is happening, where the leaflet lifecycle is happening, and how the two are talking to each other. So here we're pulling the map out into its own component. So before you remember, we were handling creating the map, we were handling all of that and adding not adding the markers, but just creating the map inside of the entire component. Here we're pulling that out. So the map on mount, it's going to create it, it's going to attach itself to a div, and then it's going to save the map ref, which is a weird leaflet thing just because we need access to the map object. You can ignore that. It's going to render this div, and then we're just going to render the children. And what that lets us do is build our own little tree of leaflet components. So we don't have to just have the DOM stuff that React is handling over here and the leaflet over here. We can actually have like a div that has a div in it, that has a map in it, that has a marker in it, and it's all just going to read like one code base. And you as the developer don't need to look, okay, and see that's where I hand it off to leaflet, and this is where I pull it back into React. So this marker component is the exact same as the one we did before, except now when you click on the marker, we're going to call this function highlight tweet, and we're going to pass it. We're going to deal with tweets. When it unmount, it removes. That's the entire life cycle of that marker. And then we have our demo app. So apologies for this giant block of code. You can pretty much ignore it. It's setting up a WebSocket to a server that I have running in the background that's listening to the Twitter servers. So what it's going to do, actually, I'll tell you what it's going to do in a second. And then we have a couple other functions. Add lat long, which is basically just going to happen whenever something adds to the map. This is going to add it to the state, which is going to set the state of tweets, and then setting the state is going to trigger another render, which is going to pass those props down to the individual markers and the actual map component. And then I don't think we need, so this is what the render looks like. There's not actually that much to it anymore, and it actually reads like you can read this render function and kind of see what's happening. There's a map. It's got a bunch of tweets that we're going to map over, which I hate that word is the same because it makes things confusing. For each one of those tweets, we're going to have a marker, and that's the map. So now looking at the render function, you can see actually what's happening on the DOM, even though things are being handled differently. And then there's going to be a highlighted tweet at the bottom, which is just its own thing sitting around. one other thing I forgot to point to up to this point that is very important. This bit right here. React components don't actually need to render anything. They need a render function. You need to give them a render function, correct? Okay, yeah. But it can just render null, and then it's not going to add an empty div to your DOM. It's not going to do anything. But so all we're using this component for is just to sync up those two life cycles together. So now, go over to the Twitter map demo. Okay. If anybody feels like playing along and has Twitter on their phone, it's listening for React.js. I'm going to wave to everybody, and I'm going to say share my location. Now tweet. Ah, somebody else tweeted and apparently tagged down here. Yeah, but that's it. So every time a tweet comes in, it's just going to add it to the state of this thing, and then it already knows, okay, for every one of those, we're going to create this marker component down in the render component, and then that marker component itself knows what it needs to do. So there's not this giant state machine that's having to coordinate all the things. You're really trying to encapsulate each individual part. This is what the map does. This is what a marker does. And then using those lifecycle methods to make the two talk to each other. Questions?
Have you found is there any overhead attached to having component class implementations for every single data item, even if it's not doing rendering, or do you see performance delta between that and sort of approach?
In theory, there could be, but it depends on what you're going to be doing with the data item as you're mapping over it. So if we didn't use the individual components and didn't have that React overhead, we're still going to be having to do stuff with it, and we're still essentially going to be listening in the same places of code and then hooking into it. So I personally haven't seen it. I haven't run extensive benchmarks, but I know that on the app that you know that I work on, I have done the naive approach, and I did not see a hit when it switched to this way. It pretty much just made the code base a lot more readable and a lot easier to work with, and a lot easier for new developers too. If you go to say, hey, we need to make the marker blue, you go to the marker component now, which is a lot easier than trying to understand this giant behemoth map and then figure out where's the marker, how does it get added, where do I update it, every time the data adds, do I need to make sure that the marker updates to, here you just hook into those lifecycle methods. Anything else? So, hopping briefly back to conclude. Okay, so I mentioned D3 before. Show of hands, who's worked with D3 before? Who's heard of D3? Okay, most people. For the people that haven't, it's a graphing library. It's, as far as front end goes, it feels very low level in that it's really abstract. You have to bind data to individual things, and then it essentially has its own set of lifecycle methods that are completely different than this, where it's got like enter, exit, and update that depend on what happens with your data. It'll run different functions on certain parts of the data. It's not pleasant. So trying to get the two of them to talk to each other usually ends up like this. In this metaphor, you're Charlie. I've done it, it's not pretty, but it's possible. The thing is, whenever you're going to marry two things up like this, you have to understand what are the lifecycle methods, where is it going to be trying to update the DOM, and where is the data coming in, and updating that for the other side too. And then figuring out how those need to talk to each other is the hard part, which we're not going to do with D3 because I don't want to put you off with that. So. Questions? Cool. I also forgot to introduce myself at the beginning. I'm Chris Brainerd. I'm a software developer here. I've been here a year and a half plus at this point. As you can tell by the subject matter, I like doing data visualization and mapping stuff. So if you have any questions, want to talk shop about that sort of stuff, I'm after. Are we done with this laptop? Yeah. Cool. All right. Let's get my sleeves up right. All right.
And I guess that's what Mary was saying.
It's actually
There's a lot of stuff.
All right, so I guess I'll start. So my talk, I'll start off. I'm Zach Sierakowski. I work with Chris and Enrique from earlier. Been here for over 2 years. So my talk is primarily about trying to communicate data between one app or tab to another app and tab. And so the motivation behind this is on the project that some of us work on is we have one app that requests data from Elasticsearch, and then later on the user might want to send that over to another app in like the tool suite. And so the first obvious way to do it would be to just do a deep link and open the app with the event that you requested. Just open the other app with the event ID, and then request it from ES again. And so what we wanted to do was try to avoid requesting from ES twice. From a UI developer or from just a user perspective, you would be like, I already have the event in the one app. Why can't I just send it right over to the other app nice and quick? You don't have to wait for the response from ES again. One thing to note, we're not able to use local storage because we didn't want the events to be stored in our browser. So that's one thing I'll get to later on the reason why we chose our approach to get this to work. And we're using Redux to accomplish this. Elasticsearch, it's a database to store large amounts of data and query them. So I'll move on. This is kind of the outline for my talk right now. I'll go through a high level of what Redux is. How many people have used Redux? Decent amount of people. So I'll try to go through it in a broad manner so that some people can get an idea of what's going on and other people won't get bored. And then I'll go through what Redux middleware is, which is more of like an advanced concept of of Redux. And I'll go through some examples, and then I'll get into how we implemented the tab communication, and then I'll do a demo of bringing those two things together, Redux and Redux middleware and the web workers for the tab communication. So Redux is basically just used to manage your state within your application. The state's read-only. To update the state, you emit actions. And then you have reducers that are just pure functions that will update the state. You never want to mutate the state itself. You should just have the reducers return a whole new state. And that pretty much relates down to the point where you want React's components to update. If you mutate the state directly, you'll have problems. The components may not update. So this is just a quick little to-do example kind of thing like Chris did. So this is an example action. You got the type, which is normally a constant, and anything else. The type is required. Everything else, you can put anything else in an action that you want. The reducer over there, it's typically a switch statement that returns a new state object based on whatever the action is you sent in. So in this example, we send in the add to do, and it just sends in a new text. So we return a new state object with the new text. Feel free to ask me questions or cut in if anybody wants to. I'm trying my best to keep this through. Yeah.
Why would you choose to use Redux when you could just use the state that's built into React?
So we'll get into that with Dylan next a little bit on how you can avoid using Redux. But the main reason that I always find that I want to use Redux is, it's basically that you would want to pass props down from top, like one component, all the way down another component. You don't have to chain them all the way down. There's also a lot of other use cases for it too, and Dylan's going to be counter-arguing that because you can get the stuff down.
You don't have to mess the props all the way through.
Yeah, exactly. So now we'll get into Redux middleware. Hopefully the basic action reducer concept is clear. So middleware just stands right between that. So you dispatch an action, it goes down to a reducer. Now you have a middleware in the middle between them that you can catch stuff and do other things that you might want to do. And you can chain them together. So you can add multiple middlewares. So reasons to use middleware, I kind of just said that, but you can do side effects. So in your middleware, you can, depending on the action type, you can do different things. You can log every action you want. You could, if an action type is an error, you can send that error off to a database. Anything asynchronous is always a good spot to put it in the middleware. And I'll just go through a couple of small examples, simple examples. This one is a really simple logging middleware. You'll see it's a queried function that has a store, a next function, which will grab the next action, and then the action itself. So what this middleware will do is it'll log every action that goes through Redux, and it'll log the resulting state after that action. This is another one, kind of what I mentioned before. If the action type, because the type's always required, if it includes the text click, this is just like a fake client, but let's say that's like connected to InfluxDB or something, you'd want to send that action up to Influx and be like, oh, that's a click, or an error. You can report that error to the database.
What is next? Is next like the next middleware, or?
Next is calling to the next middleware or to the next reducer. So it passes that action to the next one. So what you can actually do is by chaining them, if you put the first one, if one of your first middleware, you can actually mutate that action, and then you'll pass that on. The next action will get something new, and you can actually get that down to your reducers in a new format. You got to be careful with that though, because then it can get hard to read through your code.
I'm sorry, did you just say that you're going to modify the action?
You can append stuff onto it where it need be.
Isn't that kind of like the taboo thing that it just says?
No, you don't want to modify the state, the actual state of the Redux. So the state's the overall like data that you're storing and updating. The action is what you're sending off to then update the state. So you can actually intercept the action and add stuff that might be needed, which I'm going to actually show an example in a bit. You could just be adding, let's say, like the app name. Like let's say every action you want to send, you want to add the app name to it. Like just your app name's test, just throw that on there instead of having to do that in every single call.
What's the purpose of the shading?
What was that?
What is the purpose of shading? Still next
Oh, like the queried functions?
to yeah.
What's the purpose of it?
Yeah.
Don't know if I know a great answer to that.
Pretty much the way Redux middleware works. You need to, whatever you want to create a middleware exactly, you need to chain it like that. That's the way they designed it. So the first one's going to be stored, that's going to be next, and that's going to be the action. Then whatever comes afterwards, it's your middleware. So you can do whatever you want with it. So you can use store to get state, you can dispatch stuff within the middleware, then next, an action, but you can not mutate the action, you can like clone the action to a new object, pass it into next, and it just keeps going through the middleware. Next is kind of what triggers, like I'm done here, just keep going with the next middleware.
Thanks. Yeah, so basically it's the format that Redux expects it in. But you might not be familiar with that. That's ES6 format. So like that exact function you can write with the function brackets and then another function bracket inside, and it just looks a lot cleaner this way. This is just a quick example where you create your store and you can apply the middleware. And so those are the two that I just had in the example. So depending on what order you put them in there is the exact order that they'll run through. So when you call store.dispatch with an action, in that example, you go to the logger, you'll log it out, or pass it down to the metric middleware. Metric middleware will send the metrics if the action matches, and then it gets down to your actual reducers after all that happens. So now that I got through some of that, I'll talk about the actual tab communication aspect of our problem. So a couple of implementations that we came across when trying to figure out how to handle this were local storage events, which seem to be one of the best options for the browser support. It's most supported, but we weren't able to use local storage. Broadcast channel API would probably be the cleanest option, but it's not supported very much at all. So, yeah, Firefox 59 and higher, Chrome 65 and higher. Other than that, not Safari or anything. Let's see.
That's not the post message API.
What's that?
That's not the post message API.
No. But have you? It's called Broadcast Channel. It's like, it's the Broadcast Channel API, but I haven't heard of the post message one.
I'm not sure how. I just started using it. I'm not sure it's been around for a while, and I don't know what things.
Yeah, we can talk about it after if you want a bit, because I'm interested in hearing other implementations as well. If anybody else has handled multi-tab communications. So then the other one we found was web workers, and you can actually share web workers with a shared web worker file. And this one has better support, at least for us, because we needed to support like Firefox 31, so it fell right into what we needed, which was great, and it all Chrome. So this is just how you would connect up a shared worker. So there's a file hosted somewhere with the worker, JS code, which listens for the events and broadcasts them out to other connected clients. So you just make the connection with that. That's the shared worker API. It's still not supported in Safari, so it's kind of a bummer, but we didn't have to worry about that. And then you start your worker, and then you can wire up. Anytime you post a message, it'll come back through on this onMessage function that you set up. So now combining those two concepts, we use Redux middleware and we use the shared worker together to be able to take anything that we have in our state and say, all right, I want to send an action with something in my state, and I want it to go to myself in all the tabs, or just to all those tabs, or just the tabs that I'm able to communicate with. So we implemented a way to actually connect up certain tabs that we wanted to talk with. So this is back to the original diagram. And what we are trying to change it to is this. You request an ES, receive the event, and then when you're ready to send it to the other app, you just open the other app like normal. And once it's open, then it's listening on the worker, and then you just send the event through the worker, and then it just gets it. And it's really cool. I thought it was really awesome once we first got it working. So I'll go through a demo really quick to do. Super fun. So at the bottom here, you'll see there's this little hash, which is like the tab instance ID, and another hash here. So those are the unique IDs for each of these tabs that I have open. And basically, right now, if I were to type in here, test, it doesn't go over to this other guy. So let me clear that out. As soon as I press connect over here, you'll see the logs, the Redux logs, which is coming from the middleware, that it tries to connect to this one, and this one then sends one back and says I'm connected. So then now they're both connected and they know about each other. And I type in here, then they start coming through on each end. And you can see the logs coming through on each, and I come over back on this one, on this, and it's like seamless. And then you can connect to just certain ones or not. So that's the gist of that.
So without going into, I guess, confidential detail, what would you use this for outside of, I don't know, you probably have a confidential project, so what would you use this for?
I mean, I would use it. You could use it for like a shopping cart, really. If you wanted to make sure your shopping cart stayed sync. I mean, I think most people probably would just use local storage for that, and but I'm not sure how they handle it if you have two tabs open. I'm not sure if the other one updates unless you refresh.
Or
So-
like if you have Facebook and then like Facebook Messenger open, and you want to sync like the fact that you have a notification on one, send it to the messenger.
Yeah. I think they might actually just use so this doesn't have to use any back-end service at all. It's all client side, which is one benefit. So I think they probably use like a WebSocket for that, for the Facebook API. I mean Messenger.
One of the really cool things for web-based apps that are using large amounts of data or large objects, like if you had like a web-based Adobe suite and you wanted to send something from Photoshop to Illustrator, it's going to be really expensive to like send that over to a server somewhere or something, or write it onto disk and then read it back in. So for anything that's dealing with a lot of data that you want to transfer over to it, this can be a really simple thing. It's like,
Where in the life cycle would you make the connection?
So I can
Or in previous examples, like the shopping cart example, to where it's at.
the connection to the worker.
Yeah.
In this example, we connected up before we create the Redux store. Are you
Okay.
familiar with Redux, the store and everything? So we create it before we create the store, and then we send the worker object in with the store to create the middleware. And then the middleware is aware of the worker and can post from the middleware and receive. So we actually have an on message after we create the store. We have an on message callback to handle all like whether it should actually accept the message or not based on the type.
Does the old message just dispatch an action?
What was it?
When you receive a message in a different tab, you just dispatch?
Yeah, so that's part of it. So it's just listening, and then as soon as it gets it, it just dispatches it, just like a normal Redux action. So there's no really difference. You don't have to change much in your app at all. And then you, based on the type, so like the way I have this implemented here is if the type is, I think it was like register instance, then it goes to all the tabs. If it's any other type, it has to make sure that it's connected first to the other instance. But I think in most cases, you would just always want to send it to all tabs, like the shopping cart one. So that's a lot simpler. Any other questions?
Just to quick say something. So you don't really need Redux to do this. Just want to use this in a component. You can instantiate a shared worker in the constructor. For example, if you're deploying, you can just do this.worker equals use shared worker, and then it's available across your entire environment. You can use it there. Okay.
Yeah, that's a good point. So there's just a couple bullets of what to do next. You can research more middleware and try to create your own, some use cases. There's other ways to use web workers. I'm not sure if anybody else has used them in any of their apps. In one of our apps, we use them to do complex computations for a timeline, to make like a historical graph in a timeline, so it stays off the client. I mean, it's like non-blocking. And if you guys have any other questions or want to talk to me more about just tab communication stuff afterward, feel free to stop by. Do you have any other questions? Okay.
How about we take a 10-minute break, grab some more pizza, drink, whatever you need, or just find someone to talk to.
Hi everyone, my name is Dylan Mulroy, also software engineer here at Visionist. I've been working with React for probably close to 2.5 years now, so I've been in the ecosystem for quite a couple life cycles of React. Today I'm going to talk a little bit about why you might not need Redux, or really any state management library for that matter, MobX or any other popular option. And I'm going to introduce the new context API that came out with 16.3. So I know this was asked a little bit earlier, but I'm going to ask again and probe a little bit deeper. Can I get everyone raise your hand and keep your hand up if you use Redux? Of you that use Redux, how many of you install it as a dependency before you write any React code? Okay. Just want to check. Another question: how many of you have used the context API, whether it's the new one or the legacy? Cool. Okay. So to get started, what is Redux? Zach already covers a little bit. From Redux documentation, it calls it a predictable state container for JavaScript apps, which basically just means a global store for all your state and data. Something cool about Redux is that it brought on ideas from Elm and Flux, that being pretty much unidirectional data flow and not mutating your state directly. You only mutate state by dispatching serializable actions. Them being serializable kind of introduces some cool benefits like having time traveling debug or being able to play back the actions your users had in the app, recreate bugs, things like that. Zach already talked about how reducers take actions, apply them to your state, return a new copy. Basically, the reason you want to return a new copy is because if you try to use pure component or if you want to implement should component update, if you're not returning new copies, the reference is to the same object in memory, and it's not going to update generally. And there's basically a simple chart of the flow of Redux. Your view basically subscribes to your store. Your view will dispatch actions, which flow into a reducer, which update your store, which updates your view, so on and so forth. So some very common complaints with Redux is that it's really hard to learn. And a lot of people, especially people new to React, will try to come in and try to learn Redux right away. And that, kind of was hinted on in the Create React app talk earlier. Starting to learn React can be kind of intimidating if you're coming from something like jQuery or Angular. You have to learn bundlers, you have to learn Redux, you have to learn all this state management stuff, React itself, some functional programming concepts. It can get overwhelming. Kind of in a like sense, it feels like it can be a requirement with React. Like a lot of people will be like, if I'm using React, I also have to use Redux. Which is kind of why I asked you guys if you install Redux before you ever even write any React code. Another really common complaint is that it has boilerplate hell. Basically, anytime you want to add top-level state, you have to create your actions, your constants, your action creators, your reducer, wire up map dispatch to props or map state to props. It's just a lot to get done. Then also, it has the potential to bring in a lot of dependencies. If you need any sort of asynchronous actions, you're going to bring in Redux Thunk or Redux Sagas. You're probably going to have a logger. You might have Redux DevTools. You might have reselect, which is for memoizing retrieving state for performance benefits, likewise with Immutable.js. And at the very least, anytime you bring Redux in, you will have two extra dependencies that you have to maintain, being Redux and React Redux, which are the bindings for Redux. Yeah, you get the point with managing dependencies. It can become a nightmare on maintaining applications. So enter React 16.3. This was released probably somewhere in the last 2 to 3 months or so, and they basically released a new context API. They previously had an old one. I'll cover that in a little bit, but to get started with this, context API, React or Facebook describes it as a context provides a way to pass data through the component tree without having to pass props down manually at every level. Basically, this avoids a problem that you'll see referred to as prop drilling, which we talked about a little bit already, where you have state way high up in your application, but you need to get it 3, 4, 10 components deep. You don't really want to pass it through all those components that don't really care about it. So the context API is one way to do that. In addition, components that use the context API, any intermediaries between the provider, which we'll talk about, and the consumer, don't update when your context values update, which is a pretty awesome benefit. So here, I don't have a mouse, I don't think. Oh, I do. Cool. So this top image up top is the top-level API for it, attached to the React object that you're pretty much importing in all your React files anyways. You can call create context, and it's going to return to you 2 components, provider and a consumer. You can also optionally supply an argument to create context, which will be the initial value for your provider. So the next piece is the provider component. Basically, just like you would wrap your app in Redux with your provider, you wrap your app with the provider from the context API. Every provider needs a value key. You can pass anything into that. You can set state to change the value. That's what you could think of as being the store for your provider. And then below that is my component. You basically take the consumer that the create context created and wrap your component with that, and you'll get back the values out of it. So line 3 on that bottom image might look a little funky. Is anyone familiar with a React pattern known as function as children or render props? Anybody, hands up? Cool. All right, we're going to go over that quick then because that can be kind of weird. Let's see here. So I just built a quick little code sandbox. If you guys don't use code sandbox, it's really awesome for prototyping. Basically, just gives you the same setup you have with Create React App in your browser, and you can just code right away. So for this example, I built this little tiny thing. We have this React component called random number provider, and we render it right here. So one thing to step back and think about first is anything that goes between two, like a single React component, is its children. So anything between here will come in as its children. So if I just put a p tag in there instead, in that component, it's children. In this case, this is actually just a function, hence the name function as children. So we pass this function in as children to our random number provider, generate a random number, and then we call our function, which is provided right here, and we get the random number back out. You guys, everyone see how that kind of flows there? This number ends up coming out right here, and we render it here. I think this might help make it a little bit more clear. So I have this child function, which basically just will log that in the console. Just a normal function, nothing special about it. We can replace this guy right here with our function. What did I call that? Child function. And that will get passed in as children. I guess it doesn't like that. It shouldn't, it's getting called here. I just need to return something. So actually I think I can do, I wrap this parentheses. Play nice. There we go. Don't use that in production code. Comma operator, return, just don't do it. We pop open the console, we'll see it got called with this children in this case is literally just our child function, which we passed in right there. And that's child as a function or render prop, which is probably more commonly referred to as, has kind of become a better pattern or considered better practice than using higher order components. Kind of like, you could think about it as like almost like an inversion of control or like dependency type injection pattern for React components. So let's get this back up. Okay. So the React team decided to use this pattern to create their consumer thing. So basically in our example, we set the initial value to the React Maryland emojis, and down on line 3 of my component, we're getting that value back out, throwing it into an h1 tag, and down below is what you'll see rendered in the DOM, that h1. So I talked a little bit about React having a legacy context API. This code snippet right here is actually pulled straight out of the old documentation on React's website. Basically, your provider component, which is the message list in this case, needs to implement a function called getChildContext, and that's basically just going to hold the data that you want to pass a child or like children down the component hierarchy. And then on top of that, you also have to add a static property called child context types and give it a prop type. So I excluded the message component for brevity, but basically the message component you see right here just renders the button component down below. Then here you add context types to the things you want to consume a context, and then you'll have access to this.context just like you would have this.props. It's the exact same thing under the covers as the new API, just way more verbose and more boilerplate. And if you're familiar, there was a warning in the old documentation, which a lot of people considered using the context API as bad because the React team noted, if you want your application to be stable, don't use context. It is an experimental API and it is likely to break in future releases. Fortunately, they never broke it. They just moved to a new thing. So if you did use it, you played your part right. Going to give a little demo comparing two apps when using Redux, when using the new context API. I was going to do live coding, but time is not going to permit that. So fortunately, I have a completed example. If you guys want to get more used to the context API, I have this demo on my GitHub, which you can go here and you can try to make the code under this context folder work. But for now, we're going to look at the completed folder in Redux. Let me start this up. I'm going to start it up on Redux first. Should be running on 3000. So here is my app, yet another to-do app, first of its kind. Your run-of-the-mill to-do app. I even gave it some initial state, so if you guys did choose to try to implement the context, here is the order in which you should do things. So pretty standard. You can mark things as done, show your completed tasks, show your active tasks, show them all, add stuff. Pretty standard. I also have marked down here which version we're using because I'm going to have two up at once here in a few minutes. So this version is built with Redux. I don't want to say built with context API. That's actually probably going to break because this needs to point at the completed version and not the broken one. Okay, so if we look at, I'm hoping it put it on 3001. Cool, so this one's built with the context API, same deal. So let's dive into the code a little bit. So this is basically just my top level index file. Because I'm using create React app, you can create environment variables, which drives which version it renders with here. So we'll take a look at the Redux one real quick. So we go into Redux, pretty standard. You have your provider, you have your store, app, the root reducer, top level to-dos, visibility filter. The to-dos reducer has some initial state there. Add to-do, I'm pretty sure this is the exact same thing Zach had in his. I cloned this repo from the Redux code base, so basically just adds to-dos, copies everything, so on and so forth. Let's jump back into the root reducer. The visibility filter is just a string in state that gets set. We have some actions, add to do, set visibility filter, toggle, and just some constants. So our components in this application, they are the same for both the context API and Redux. We'll start at our app and work down. Actually, I think I might split screen on this and show you guys side by side the components the whole way down. We'll start at cool. I'm going to have Redux on the right and the context on the left. This is different files, but that's okay. So here, start from the top down. Both have left context, right Redux. We have our provider. You get the store. In this case, we have a to-do provider and a visibility provider. So we go take a quick look at the to-do provider. We get this guy over here. You can see the top level React thing. I create a provider and a consumer. And then I like to personally wrap my providers to give it more functionality. I export everything from the same file. So here I have my state. I put my callbacks for setting state or updating the state within the provider right in here. Add to do, same action as Redux, toggle to do. And then we return the provider, the value of this.state. And then we pass the children in. I export default as the provider, and I export a consumer and a provider. Pretty straightforward. And it's basically the same thing for the visibility filter provider. Nope, wrong file. Look here, same kind of class. It looks basically identical. And here we're basically just using straight up callbacks as you would data down, actions up. So the providers, same as Redux's provider. And we have our app, which we have open. We have our add to do, visibility list, visibility filters. We take a look at the add to do in the context. Basically just a component that renders a form, same as over here. In the Redux's case, we're using the bindings from React Redux. We're using the connect higher order component to retrieve state from the store and add the add to do action creator to our props. Over here, we're actually using our to do consumer with a similar function as a child callback. Here we're getting our add to do from our consumer or our context rather than getting it from Redux. So fundamentally, very similar paradigms. Just a little bit different syntax, and with the context version, no dependencies. So if we come back up, let's look at another example. We'll look at the visible to-do list. Oh, that's funky. So here we have a to-do list which requires to-dos and the visibility filter. So we just kind of nest our consumers. We get the to-dos out of there, grab the visibility filter out of there, pass it in our to-do list. Yeah.
Why do you choose to separate the providers into two different components versus having one context provider?
So you could, probably for testability and separation of concerns. I'm going to show.
You have a lot of them then? You have
Right.
a lot of different like actions and reducers?
I have a little bonus helper function. I implemented it for the providers, not for consumers, but basically a way. So Redux has compose reducers. I also wrote a little helper function for compose providers. Kind of the same idea. So you don't get like what would end up looking like your traditional pyramid of death type situation here with callbacks. I'll get to that here in a little bit though. Let me launch this guy for comparison. A little bit different, but we're connecting the to-do list, basically passing the same stuff in at the end. So we get our to-dos visibility filter from the parent, map over it, filtering it based on whatever the visibility filter is, then we render to-dos. So here, I didn't want to pass, this is kind of a contrived example because it's only 2 components deep, but I also wrapped my to-do in a to-do consumer. I felt like it really wasn't the responsibility of the to-do list to handle the toggle to-do for each individual to-do. So you could think of this being deeper down the hierarchy, but here you can see kind of how you can easily separate the concerns of your components using the context API. So we just pluck the toggle to do off the state because we're returning the entire state from the provider. So we can destructure it off and just provide it in as easy as that. When we click on click, it's going to call the callback that came from our provider, update the state in the provider, and anything that's wrapped at the consumer will update and nothing in between.
It's like providing actions to different components the same way Redux does, essentially.
Right, and basically if you stepped into the to-do list on here, you're going to see very similar things, just it'll be connected, so on and so forth. And last example, I suppose, will be the visibility filters. If you look at this guy, basically this visibility filters is just a constant file where it's show all, show, we're just mapping over the values. I accidentally closed that. Mapping over the values, creating visibility filter buttons, keying it with the name, and providing the filter for it. And then the text on the button is the name of the filter, so completed, all active. If we look at our button, again, we're using the visibility consumer, and we're plucking the filter state from our visibility provider, and we're plucking the callback to set state in the provider, and just giving it to our button. Pretty straightforward. Do I have anything else here? I think that's the bulk of how you kind of implement it. Like I said, I wanted to kind of walk through it and actually code it for you guys, but because of time reasons, I would really recommend walking through the context folder I have on there and trying to re-implement some of this stuff yourself. So I'll show to avoid like the nested. So like I said, I only implemented this helper function for the providers. You can do the same thing for consumers. So you can avoid, like, let's say you have like 10, 20 different pieces of like top level state. You don't want like to-do provider, visibility provider, user provider, so on and so forth. I wrote just this real simple, well, maybe not real simple, but that'll be for you guys to decide. Basically, this composed providers, you send in an array of your providers, and as long as you always like, are you guys familiar with destructuring arrays? So right here, this is an easy way to like get your head and the tail of an array. Basically here, I'm just popping off the first item, and then this is the rest of the array. As long as the top item is defined, I clone the element, I don't add any props, and I recall compose providers the whole way down. So it composes all my providers into one component, and then I return that. And you can see, if I open this up, I have an index file in here, which here's my provider component. You just call it, give it an array of components, pass it children at the end, and you can pretty much come in here and do state, help these guys out. Pretty much just like that. And that should work, knock on wood. Yeah, still there. So, and you can basically fundamentally do the same idea with your consumers as well. And in fact, there's also a library out there called Restated, which basically does the same thing as that function, just probably in a way more performant way with a better API. So, your choice on adding dependencies. All right, let's get back to the rest of this presentation. So, what if I told you that Redux actually uses the context API? Spoiler alert, it does. And in fact, it uses the legacy API. So if you've been using Redux, you've been using the same API that's been experimental and that the React team said not to use. This is actually the provider component from the current release of Redux right now. You can see it implements get child context and the child context types. So surprise, you've been using context all along. To summarize, new Context API came out in 16.3. Definitely recommend checking out. You should reach for the Context API when lifting state becomes hard and it starts introducing multiple levels of prop chilling. If you're not familiar with lifting state, that basically means you want to create a parent component for two children components that may not be siblings that need to have access to the same state. Also, the added benefit of having zero dependencies and just being plain old React and having similar ideas that someone new to React already know, that is passing down props and callbacks to update state. And you might not need Redux. If you have any questions, you can find me at all these places. Like I said, that code and the slides are on my GitHub. Yeah. Questions, comments, concerns, complaints?
Is there ever any situation where you use both context and Redux?
You could.
Is there anything context does that Redux doesn't do? That might be a use case.
Out of the box, I don't think Redux will buy you not updating any components between. Well, actually, it probably does because it is using
Because
context.
it's just passing prompts
Yeah.
to individual components.
Can you do the same demo he did with the communication between apps with the context API?
Yeah.
Like right now?
No, not right now.
So an example would be like, let's say you have a map in your application and you want access to that ref, like the ref that pretty much the leaf ref, and you don't want to keep that ref state in Redux. You might just want to access it down the tree. You don't really want to keep the ref state. You just want to access it from this component down in the tree. You can do that using the context API. You can expose that a function that just returns the ref that a child like deep in your tree can just call, has access to the ref, and can do stuff in the leaflet map you have rendered all the way up here. That's one example. I think we use it.
Can you go back to the link to your GitHub for this demo?
Yeah, absolutely. Bueller? Anyone? All right.
So I'm going to post all the links, all of the slide links, various GitHub replies, whatever. All of it will be posted on the Meetup page, so you can get access to all the content. And yeah, that's it. That's all the talks we had. People are welcome to hang out for a little while. Please take pizza, take all of this food. I don't want it. Eat it. Take a whole pizza. It's fine. And hopefully we'll see you next time.